Hi. BERT is a superpowered language understanding machine. It is designed to truly grasp the context of word in sentence, making it incredibly good at tasks like answering questions, figuring out sentence meaning, and classifying text. In this lecture, what we will learn what is BERT, how question answering model works, Python implementation of BERT. You can see BERT's goal is to understand the relationship between words in a sentence, not just read them in order. It's like teaching a computer to read between the lines. Okay, so it's created by Google, which stands for Bidirectional Encoder Representation from Transformers, and it is made up of encoder layer. Here you can see this is showing encoder layer of the transformer with 12 layers instead of 6 layers in the transformer models. BERT is a model with absolute position embedding, so it's usually advised to pad the inputs on the right rather than left. BERT was trained with the masked language model (MLM) and next sentence prediction (NSP) objectives. It's efficient at predicting mask tokens and NLU in general, but is not optimal for text generation. So this is going to show BERT base and BERT large. There are two formats are available for this one. So it is also using BERT tokenizer. Here you can see this architecture is not showing, but the another concept represent it is also using BERT tokenizer, something known as subword based tokenization. So subword tokenization splits unknown words into smaller words or characters, such as the model can derive same meaning from the tokens. For example, boys is divided into boy and s. BERT uses word piece algorithm to generate the vocabulary. Word piece algorithm generates subwords based on the likelihood of characters occurring together. So what is BERT? What is the bidirection context? Everything is written here. I cannot explain everything in Dex because we need to move to Python implementation as well. As far as transformers are concerned, here you can see it is also using pre-train and fine-tuning. It is using pre-training. BERT learns massive amount of text like the entire internet. It helps it understanding language rules, and also fine-tuning. It is then adapting the specific task like answering question or analyzing documents, making it highly flexible and generating outputs. Its output is word embedding, which are numerical representation of words that capture their meaning in context. So these embeddings are then used various NLP tasks like ChatBot, search engines, and more. What is the architecture of BERT? Here you can see we are using generally two format. First is 12 layers, 768 dimensions, hidden representation, 12 attention heads in each self attention module. 110 million parameters are available. There is a large architecture available which is having 24 layers, 1024 dimension hidden representation, 16 attention heads in each self attention module, and 340 million parameters. Okay, so these are basic architectures. Let's move to the Python implementation of this code. First, I'm going to use this one as this one. So these are basic libraries for these terms. Okay, so I'm going to use this terms as well. Okay, so this is nothing, so I'm going to change one. So these libraries, BERT for question answering, BERT tokenizer, torch, I'm just importing this one. Then I'm going to load my model and tokenizer. So this is the model name, BERT large uncased. Uncased means this is not differentiating between uppercase and lowercase. Both are same. And whole world masking fine tuning squared. So this is the model which we are going to import. So I had already imported this model. It's not taking much time. If it is very first time for you, it will take some minutes or few seconds as well. Here you can see cased characters which are either lowercase or uppercase. So this case model is case sensitive. It makes difference between small e and capital E, whereas uncased characters are either uppercase nor neither uppercase nor lowercase. This model is uncased. If you want to see, you can go back here anytime and you can see this is a resource for every model here. So I'm going to import BERT for question answering. This is just importing BERT for question answering from pre-train. I'm going to pre-train this model name. So I'm just assigning this model here. Okay, you can ignore these warnings, and then I'm going to use this tokenizer. So this tokenizer, from the BERT tokenizer from pre-train, I'm going to define this model name. Let's do embedding. So what is the question? I'm going to assign that question. This would be example question and text containing the answer as well. So I'm going to provide this question answer, and this would be the answer document. Let's encode, and this would be tokenizer and encode plus. So this is the first text taking as the question, and then text pair as the answer, and then I'm going to encode this one. So this encoding object will be consisting three parts. First is the input ID, which is tokenized numerical representation of the input text. Second is the attention mask, a mask that indicates which token should be attended, 1 for real, 0 for padding. Third one is token type IDs, distinguish between text and text pair, for 0 for the question and 1 for document. So here we have ingested two things, questions and answer. So this token type IDs will differentiate in between these two. Now let's see how these encodings will be there. So let's print it out, how these are printing everything. Let's see. Here you can see first one is the input ID, which is just explaining here. Second one is showing here token type IDs. So can you see this is illustrated over here? And for quick review of this attention mask, you can see this is attention mask. So 1 for real token, 0 for padding. So we do not have any padding, it's not showing any 0 value here. So this token ID is again 0 for question. So can you see this, these terms are for questions only. Okay, later on we can define the other parts. Let's define these encoding in different ways. So I'm going to define the input IDs, token types, tokenizer, and convert it into tokens. Let's see, let's decode this part, the tokens, individual tokens. Here you can see this is showing CLS. This is the classification part we have seen earlier in the previous sessions. Let's see let's decode other part. For example, I'm decoding 102. It's going to SAP, which means separator. So this is having so many different keywords there. Let's define some input IDs and converting TensorFlow. These are also converting into TensorFlow, and we are assigning to output variable. So the main point we have covered so far, we have imported a model, we have just encoded, we converted it to tokenizer, and then define in our tensor format. Then if anyone working with a question answering model, while the model predicts the start and end position of the answer in a given passage, output.start logits and output.end logits are there. So these are two indexing module, those are defining differentially. So here we have a start index and here we have ending index. Now I'm going to define these two texts. These are correct response. If you want to see, this one is the correct index. Can you see this is showing March 24, 1997. In this question answer, you can see this is the index value. Okay, so this is the start and ending index according to question answer. Now I'm going to import matplotlib for my graph representation and Seaborn for the basic plotting responsibility. If you do not have Seaborn library in your Jupyter notebook, you will have to run this cell pip install Seaborn to import Seaborn as SNN successfully. Now I'm going to create these two scores using this terms output dot logit detach and end dot logit, and going to convert into numpy and then flatten. What's the difference? Because if you are going to define this output, for example, I'm going to print this output. Can you see it's giving in a tensor format, and it's giving something relevant row and versus matrix. Whereas if you are defining this value, this would be something relevant array format. This is tensor format, this is a array format. So we are converting every tensor value in a array format. So I'm going to comment this cell, as well, but you can see the other variables values as well. Now I'm going to convert these tokens. From these token labels, I'm going to define these terms. I'm going to enumerate these tokens. I'm going to append this part and going to bar plot for the same values. Can you see this is defining everything here? Now you can see these terms are defining in upper values. Those are my answers and key features, and rest are showing in a lower part. If you want to see the bar plot for my token labels and E score, because this is the S score, and I'm going to define this E score as well. So here is the relevant graph. Can you see this is also showing the E score for this one? Okay, let's see what is the question answer, how we can ask any question from the given values. So I'm going to ask this question. Sunset Motors is defining, this is real fact and paragraph. If you are keen to get started with question answer, you will have to assign this paragraph to a single statement and then print the relevant value. So what will happen? I'm going to define some question answer for these parameters. Let's see what would be the answer. But before this, I'll have to define a function which is going to define my corrected values. Okay, so here I'm going to define this fake bot, and this is going to define my context, and these contexts are first encoding and then convert to ID tokens, and then defining these index values and the numbers, and everything is defining TensorFlow and converted into arguments, and then going to join this value, and if it is not having that answer from the given text, it will provide this value. I don't know how to answer this question. Can you ask another one? Otherwise it will give relevant answer. Let's run this cell so that we can define this fake bot method. So I'm going to ask some question from this value. What is a dealership located? Let's see what is the first question. Can you see it's searching from that paragraph and finding this question, where is the leadership located? Can you see Crestwood is the correct answer. Let's ask another question from the given paragraph. What makes of cars are available? Can you see it's searching that question and giving that value. These are few questions, few cars available from the given text. How large is the dealership? Can you see? So main points we have discussed. It's giving complete understanding of this question answering. Let's go back and find some teleperformance case study. I'm going to click on this link so that we can go back to this paragraph. Can you see it's giving this getting this list, and this from this hyperlink I'm going to provide this question answer. So what is the case study 1? So I'm going to import this case study 1 for the same website, teleperformance website. So I'm going to provide this. A global leader is a technology innovation. Let's see here. I can see the paragraph. Okay, so this would be some paragraph or this one. Okay, might be no, this there might be some other link. Okay, so from the given link I have provided every text here. You can see this is AI powered tools and insights, and this is called AI powered automation, and these are chatbots integrated. This is some paragraph. So I'm going to define this paragraph here. Let's run this cell. Can you see this is giving these AI powered chatbot integration existing customer channels. Now let's see case study 1 based question. What is the question I'm going to ask? First question I'm going to ask from this chatbot, that what are the 3 ways AI powered chatbot were integrated into existing customers. Okay, it's just find that questions. First one is AI powered, second is the multi-channel, third one is the integration continuous program. Can you see this is giving 3 points from the given text. Successfully parsing that questions. So I'm going to ask second question from the given paragraph. So here I'm going to ask how many years of continuous improvement and innovation. Can you see it's giving the question is not given, okay, which is the case study 2. Okay, let's see what is the case study 2 from the given paragraph. So I'm going to ask second question. This is the case study 2. So we have the knowledge, 46 years of continuous improvement, 174, and so on. For example, these numerical values are there. You can copy paste and these text, and you can ask the question regarding numerical context, numerical values, particular analytics part, and other facts. So I'm going to provide this paragraph and giving the running this cell. Can you see this is giving 46 years of continuous improvement and continuous served from Europe to Asia and so on. Let's ask this question again from case study number 2. Can you see it's giving 46 because my question was how many years of continuous improvement and innovation. Can you go back here? This sentence says 46 years, which means this is the correct answer. Let's ask question number 2 from case study 2. So I'm going to ask how many countries with a TP presence. Can you see it's giving 100? Let's check this answer. Yes, 100 countries with a TP presence, which is very true answer. Let's ask another question from the given factor. How many countries served from Europe to Asia, from Africa to America? So it's giving answer 170. So can you see this is giving 170 countries served, which means this is giving absolute correct answer. You can go back here from this link and you can ask the question from the given question answer. It is giving perfectly correct chatbot answer. How would you import another model from the given link? You can run this model where model name is Roberta base and their responsibility would obviously different. This is different BERT model, this is different distilled model, and their specialization will be different. And what is that so far we discussed regarding only BERT model. Here we are discussing little bit advanced models there. So they are using general, not specifically for certain task. If you want to use another model, for example, this one is a model name distill BERT based uncased, you can use this model as well in order to leverage out of the box functionality of BERT, and your case study is mighty different. So you can research these models and you can check which is the better performance, which is giving better output on the base of these giving. So this is our progress on ongoing chatbot model, and you can give the proper question answer values. Thank you.